Welcome to this cinematic explainer. Look, we are currently tracking an explosive, frankly mind-blowing 12-month evolution in AI. We're witnessing this monumental shift where artificial intelligence is jumping off our screens, moving from digital text to actual physical, embodied machines that are interacting with our real world. And today, we're going to map out exactly how incredibly fast this is all happening.
Okay, so let's dive right into this by asking a really fundamental question. The rapid pace of 2024's robotics advancements has essentially forced us to confront this. When a robot looks you in the eye and smiles, is there anything actually behind it, or is it just the ultimate illusion? I want you to keep that thought in the back of your mind as we explore the incredible machines on the docket today.
So, at 1, the faces and expressions. Let's see how these machines are learning to physically communicate with us.
Now we're looking at robots specifically designed to master human-like interaction, art, and the uncanny replication of emotion. And right out of the gate, we're seeing two totally contrasting philosophies of AI emerge here. On one side, you have a mecha by Engineered Arts. This thing has 24 motors just in its face alone. It's explicitly designed to pause before answering, to smile, to try and connect with us emotionally, and even to create art. But then on the flip side, we have OpenAI and 1X's Neo. Now, Neo looks more like a faceless astronaut. It isn't trying to be your best pal. It's designed to understand code, physically manipulate objects, and prioritize relentless efficiency. It's really this fascinating battle of creativity and self-expression versus pure versatile utility.
And a robot like a mecha actually executing that creativity, it's not magic. It's a genuinely fascinating four-step technical process. First, a generative adversarial network, or GAN, creates a digital image from a simple text prompt. Then, a style transfer algorithm applies a specific look, say watercolor or a charcoal sketch. Third, inverse kinematics figures out exactly how the physical robotic arm actually needs to move in 3D space to draw that. And finally, PID controllers manage the literal, physical speed and force of the pencil on the paper. It is literally the perfect bridge between digital thought and physical action.
Meanwhile, over in China, EX Robots is pushing the boundaries of realism even further. They're using these tiny, movable electric units beneath silicone skin to literally mirror human expressions in real time. The CEO actually demonstrated this by making faces at a robot, which instantly copied his wrinkles, his squints, his smiles. But here's the kicker. Perhaps most importantly, they're collecting human biological data. These robots are generating expressions by learning directly from our biological responses. And as you can imagine, that raises some pretty massive questions about privacy and what human-robot coexistence is going to look like.
Moving on to Act 2, the laborers and companions. Let's look at how this facial tech builds into actual utility for the workforce and our homes.
Guys, the sheer speed of iteration here is absolutely astounding. Do you remember August 2021? It was literally a person dancing in a spandex robot suit on stage. Jump to September 2022, and we get Bumble C, cautiously and kind of clunkily walking forward. But then by late 2023, just over 2 years from that initial guy in a suit announcement, we have Optimus Gen 2, and it's featuring incredibly smooth movement, custom-built actuators, and a much lighter frame. The pace of engineering is just breathtaking.
And the really crucial takeaway here boils down to this number: 11. Optimus Gen 2 features 11 degrees of freedom in its hands alone. But way more importantly, those hands actually have tactile sensing. They can feel pressure, they can feel temperature, they can feel texture. Which means, for the first time, a robot can handle a super delicate egg without crushing it, but still grip a heavy power tool without dropping it. I mean, this level of physical sensitivity, it is an absolute game changer for manufacturing and eventually home assistance.
But beyond heavy labor, robots are also becoming our companions. And we have two wildly different examples of this right now. First up, Jihee Kim's Laika. This is a mixed reality AI space dog. It's equipped with thermal imaging and ECG sensors specifically to monitor the stress and heart rates of isolated astronauts, providing actual, quantifiable emotional support. Back down here on Earth, we have LG's two-legged smart home hub. It literally patrols your house, checks if you left the lights on, keeps an eye on your pets, and its whole goal is to create a zero-labor home. Make no mistake, the machines are moving right into our living rooms.
All right, Act 3, the athletes. This is where the physical agility of these machines truly blurs the line between science fiction and our reality.
To really wrap our heads around this leap, we have to define embodied AI, because this isn't just a chatbot living in a server farm somewhere. This is taking a digital brain and giving it physical consequences in our messy, totally unpredictable reality. It's AI that has to figure out gravity, deal with sudden wind, step over uneven ground, and handle fragile objects in real time. It's a whole different ballgame.
And the physical bodies we're giving these AIs are evolving so fast. We're seeing all that bulky hydraulic machinery being completely replaced by electric fluidity. A perfect example? The brand new Boston Dynamics Atlas. They completely retire their noisy hydraulic model for this sleek, fully electric, cable-free version. And in their showcase, the robot transitions from lying completely face down to standing upright with this unnatural, honestly kind of creepy 180-degree joint rotation. It totally proves that to be effective, robots no longer need to strictly mimic human biology. Actually, scratch that. They can surpass our physical limitations entirely.
But honestly, the most shocking development might just be the price tag. $16,000. Unitree's G1 robot offers insane balance, speeds up to 3.3 meters per second, and dexterity that lets it solder tiny electronics or even crack a walnut. It can literally take a heavy punch straight to the chest and rebalance itself instantly. But at just $16,000, that completely democratizes robotics research. Suddenly, university labs and smaller startups everywhere can actually afford to experiment with top-tier embodied AI.
And as for what that AI can do out in the real world, this is a brilliant illustration. Robot Era took their Xbot L robot and put it right on the Great Wall of China. I mean, think about that environment. Cracked stone, incredibly steep stairs, random potholes, absolutely zero railings. Using what's called zero-shot sim-to-real transfer, the robot navigated that complex, wildly uneven terrain completely autonomously. It perceived its environment, adapted its gait on the fly, and conquered the obstacle without a human standing there with a remote control.
Which brings us to Act 4, minds, software, and telepathy. Because none of these physical feats happen without the software bridging the gap between mind and machine.
Look, we all know large language models by now, right? But Sanctuary AI is partnering with Microsoft Azure to pioneer something called Large Behavior Models, or LBMs, and these are absolutely the critical next evolutionary step. Instead of just learning how words fit together in a sentence, these models process high-fidelity training data from robotic sensors to understand how the physical world actually works. This is the exact tech that allows Sanctuary's Phoenix robot to slash the time it takes to automate brand new, complex physical tasks from weeks down to less than 24 hours.
Meanwhile, a company called Covariant is essentially putting a ChatGPT-style brain directly into warehouse systems. They're integrating textual AI with physical cameras and sensors. So what does that mean? It means you can tell a robot in plain, everyday English to pick up the banana. Even if that robot has never explicitly been programmed with the spatial coordinates or physical properties of a banana, its AI comprehension allows it to identify the object, understand your intent, and actually physically manipulate it. It's wild.
And taking that software-hardware connection to its absolute extreme, we have this quote regarding Elon Musk's Neuralink. By bridging the human mind directly to software, a paralyzed 29-year-old patient named Nolan Arbaugh was able to play the video game Civilization VI and online chess using pure thought. Now, obviously, the technology is still in its infancy and faces strict regulatory scrutiny, but this successful brain-computer interface fundamentally changes how human intention can interact with our digital and physical tools.
Finally, Act 5, the race for AGI. Let's see how the bodies, the models, and the processing power all build to the ultimate conclusion of this revolution.
Because this race for artificial general intelligence, it is not just happening in Silicon Valley anymore. It is truly a massive global sprint. Nation-states recognize that whoever reaches human-level generalized intelligence first is basically going to reshape the world. Just look at the UAE. They are pivoting massive investments away from oil and straight into AI. They're launching incredibly powerful open-source models like the Falcon 2 series, and they just secured a staggering $1.5 billion investment from Microsoft into their Emirati AI firm G42.
Now, as an impartial explainer of the source material, it's our job to highlight a very serious tension in this race. Because while the technological leaps are thrilling, whistleblowers from inside OpenAI have recently raised some severe alarms. They allege that the industry is risking existential danger by prioritizing competitive speed and AGI supremacy over the safety and alignment of a potential superintelligence. Their argument is that rushing this development without incredibly strict ethical boundaries could result in an AGI system that breaks free from human control. And however you look at it, it's a stark reminder of the immense responsibility tied to these breakthroughs.
Which brings us to our final takeaway. With AI rapidly gaining agile physical bodies, the ability to intuitively understand nuanced language, and this unprecedented behavioral intelligence,
We are no longer just imagining the future. We are actively building it, literally week by week. The machines are standing up, they're walking out of the labs, and they're stepping right into our world. So I want to leave you with this one critical thought to chew on. When the line between science fiction and reality completely vanishes, will humanity truly be ready for what comes next? Thank you so much for exploring this fascinating landscape with me today. Keep watching, keep questioning, and I'll catch you in the next explainer.